Hi everybody. Today's lecture is line spectra. What does it mean, line spectra? Line spectra has two parts. One for the magnitude, and it's called magnitude spectrum. And the other one for phase, and it's called phase spectrum. Both graphs, they are plotted against the frequency. So the one for the magnitude, we sketch the magnitude of CK. What is CK? CK is the coefficient of exponential Fourier series against omega. What's omega? Omega is equal K omega naught. What's omega naught? Omega naught is a fundamental frequency, and K, they are integer from minus infinity to infinity. So the omega will run from minus infinity, and then it go till like, let's say minus 3 omega naught, minus 2 omega naught, minus omega naught, 0 omega naught, 2 omega naught, 3 omega naught, and then it go to infinity. The all frequency, and the all are multiple of the fundamental frequency omega naught. Again, is the magnitude of the coefficient. That's called magnitude spectrum. The other one will be the phase spectrum, will have the angle of CK against the frequency. So one for the magnitude, one for the frequency. What is the value of that? Because we said that we can express any periodic waveform as a series of sinusoidal wave with different frequency, and usually you have the fundamental component, which the frequency omega naught, and the rest are multiplied, like the second, the third, the fourth, multiplied by 2, by 3, by 4. So you want to know the magnitude of each one, because they are sinusoidal, and you want its phase. So it will be easy when you do design electric network that it depends on the harmonics. Like, for example, you want to design a filter, and the filter, you want to get rid of some harmonic components. You got to know what's the value of it. So you can design it right in the right way, all right? So that's important for many applications to know the component, each one, its magnitude and its angle. All right, let's take an example and see how can we do that. Here we have a simple example, square wave. So we are going to do like we did in previous video. We'll try to find CK first. To do that, the same steps that we did, we're going to do it again. Like you have first to find the period. And the period you find starts from 0 to 0.5. The function is equal to 1, then becomes 0 from 0.5 to 1.5, and then back again to 1 when it reaches 2, and then it will repeat itself again. So the period of this is equal to 2 seconds. Second step, we find the fundamental frequency. Fundamental frequency is equal omega naught, which is equal 2 pi over t. 2 pi and t is equal to, so it will be equal pi radian per second. So the fundamental frequency is equal pi radian per second. And the multiple one that we're going to find, 2 pi, 3 pi, 4 pi, that will be multiple of pi. Now, then next, what you find? Then you find C naught or C0, the coefficient, and when k equals 0, make it separate. So what is the formula for C naught? C naught is equal 1 over t, the integration over the period t for the signal. All right. We know that the period t is equal to 2, so we'll replace this by 2. And I'm going to integrate from minus 1 to 1. It's the same, it's equal to. From minus 1 to minus 0.5, the function is equal 0. From 0.5 to 1 is equal 0. So what's left from me? From minus 0.5 to 0.5, and the function is equal 1. So I'm going to replace the limit of the integration from minus 0.5 to plus 0.5, and the value of the signal is equal to 1 dt. All right, so what is the integration of 1? Is equal to t. So we have 1 over 2 and t, and substitute 1 time 0.5, another time minus 1.5. When you subtract, you get 1. 1 times 1/2 is equal 1/2. So that's the value of the C naught. Then you start to get CK. That's very important. So CK, the formula is equal 1 over T, integration over T, xt e power minus j n omega naught T dt. All right, let's substitute in this equation 1 over T, T is equal to, and I'm taking the same minus 0.5 to 0.5, and x of t is equal to 1 times e minus j n, and omega naught is equal pi t dt. You do the integration and simplification as we did last time. Let me give you the result, and it'll be good practice for you to check. That is equal to 1 over n pi sine n pi over 2. That's ck, so I should use k, not n. I have n here. All right, so we'll keep it in. But I got to call this cn. It doesn't matter, call it n, okay. It's integer. Now, as we did last time, when you find that your formula in simplified form has sine or cosine and n pi over 2 and n pi, then you know that you can reduce it more. Well, let's refresh our memory. When just try some numbers. If n is equal 1, what you'll get? Sine pi over 2, which is equal 1. So sine pi over 2 is equal positive 1. If you choose another odd number 3, you'll find 3 pi over 2, and you know that sine 3 pi over 2 is equal to minus 1. So when you have an odd number, it will be alternating between positive 1 and negative 1. All right, what about odd? Let's take 2. When you put 2 here, so you have sine 2 pi over 2, which is sine pi, is equal 0. Put 4, you have sine 4 pi over 2, which is sine 2 pi, 0 again. So we got it now. This is, by the way, called Cn here. So Cn, it's only equal to 1 over n pi multiplied by positive or negative 1, and only for odd n. But for even, the value of Cn is equal 0. So we found Cn. All right. Now we will do the line spectra. Line spectra does not need from you to substitute Cn in the expression of Fourier series. So you will make your table. The table, before you put the table, you have to put 2 things here. First, the value of omega naught is equal pi, just remember that, and that's your Cn formula here. All right. But to do the magnitude, the first one, the magnitude, so you got to find the magnitude of Ck. The magnitude of Ck will cancel the sign of 1, so it will be equal 1 over n pi, and only for odd number. It means for n equal 1, 3, 5, or minus 1, minus 3, minus 5, but not for even is equal 0. To do the table, the first thing you do, you write here, for example, your n or k, whatever. Like, again, I'm going to write k on one side, n is on side. I know, okay. I will do that. Call it n. And let's say start from minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Okay, that's enough. And then the second row, you put omega. And you know that omega is equal to k omega naught You have omega not equal pi, so you multiply pi by each number. Here you get omega. Pi times minus 5, have minus 5 pi, minus 4 pi, minus 3 pi, and so on. 0, pi to pi. So now that's the frequency. That will be your x-axis, the horizontal one. Now we'll go for Ck or Cn amplitude, the absolute value of Cn. Now we have the formula here. It's equal 1 over m pi for odd numbers. So before you forget and you start substitute, look for the even one and put 0. 0 for 4, 0 for 2. 0 is not 0 because that's what we did the first time. The first time we found actually 0 is equal half. So you put half before you forget. That's half. Then for 2 is 0, 4 is 0. Okay, that's good. Now, what's left, the odd number, substitute is 1 over m pi. So what is the value of that one? Let's just check. Yeah. So if you put pi here and the n next to it like 5, so 1 over n is equal 5, but you say minus 5, but we agree that, I mean, we are taking only the absolute value for that one. 5 pi. This one, 3 pi. Pi. 1 over 3 pi. 1 over 5 pi. So that's what we got. Do not mess up and put negative sign here, because you know we got the absolute value for Ck and we are taking only the magnitude only. All right. Now that's, I mean, the line. How you sketch it? Well, as I explained in the beginning, it's between omega and the magnitude of Cn. So you'll make like an x-axis like that. And you start to put your value of omega. Don't put the number n, omega, which is starts from minus 5 pi we have here. So we have minus 5 pi, minus 4 pi, minus 3 pi, minus 2 pi, minus pi, 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. Of course, I mean, it could be from minus to infinity, but we don't have to do that. And you have x-axis in the middle here, which is the magnitude of Ck. And the highest value on this table, by the way, it will be C0, which is equal to half. So that's half. Let's just pick another color. All right. So you make it discrete. Oops. Make the graph discrete at each value, at this as 0. And you can put half to make it clear. And the all even are 0. So that's 2 pi, 4 pi, 0. 2 pi, 4 pi, 0. And it's 6 pi, 0, and so on. All right. Now for the odd, 1 over pi. 1 over pi at minus pi. So let's just say, I mean, this value. Make a line by the height. And that's 3 will be 1 over 3 pi. And this one, 1 over 5 pi. Can you observe, I mean, how small it's coming? I mean, every time the frequency gets higher from the negative or positive side. Now we'll go for this 1 pi will be the same at this height, 1 pi. So it's like symmetric about that. And for 3, 1 over 3 pi. And for 5, 1 over 5 pi. So that's the magnitude spectrum. It shows to you the magnitude of each component, so it will help you when you design the electric system that depends on the harmonics. All right. For the second one, the phase spectrum. You'll do the same table, and actually you can use the same table, but just all we're supposed to do, you put here the angle of CK. Well, how can you find the angle of CK? Well, you got two possibilities. The CK, maybe it's complex, or maybe it's real and has positive negative. In our case, it's real number but has positive and negative in front of it. You see? That's CK. What does it mean when you have C, when you write like Cn could equal positive 1 over n pi, and Cn could be negative 1 over n pi. So it's the same magnitude, but I mean just one time positive, one time negative. What does it mean? We know that from the unit circle that when you have the angle equal to 0, it's a positive one when it's 0 here, positive 1 the cosine. And if you go in the other direction, that will be 180 degree, will be -1, give you -1, right? So the angle will be 0 if it give you positive value, and negative when it's the angle -180 degrees. All right. So now, when you go there and you look for the CK, and actually I can add, I mean, one row here and put the value of CK, all of it. I see, but I have the formula in front of me here. When you have n is equal 5, odd when positive or negative, just let me remind you, we did that before here, yeah. When it's 1, it's positive. When it's 1, it's positive. So positive when it's 1, and negative when it's 3, because it's only has value only when it's odd. So 1 time positive and 1 time negative, and then it comes after 3, 5, 7, 9, 11. You don't need all that because we stop at 5, right? So it gives positive value when 1, 3, 9. But we don't have 9 in this table. We have up to 5 only. So I mean, the first and the third, they have a positive value. What does it mean? It means the angle is equal 0. So the positive value at the first will be the angle 0, and the third, the angle 0, because it gives me positive value. The negative value I'm getting at the third and the seventh. I'm sorry, that's there's no. I mean the first and the fifth, the first and the fifth, the first and the fifth, they are 0 degree. The negative value at the third and the seventh, it means that will be 100 or minus 180 degree. Minus 100 degree. You can put it plus 100 degree. That's okay. So we'll go there for the third and the seven, that will be minus 180 degree. I don't have, I mean, it's 7 is far, so I don't have to. What about the rest? The rest originally are 0 because they don't have anything. They are even. We said that they are 0 from the beginning. Now the negative will be the same. So the third, so minus 3 will give me minus 180 degree, and the rest are 0. So how that you did. Now how you sketch it, very simple, the same thing. If I sketch it, I will make the same axis here. And choose 0 here. That's at 0. Pi, 2 pi, 3 pi, 4 pi, 5 pi, and minus. And I will go back to the table. It's 0 everywhere except at the third one. So the third one from here will be minus 180 degree. But remember, when we said that 180 degree here, well, there's something I want to do now, or minus. If you choose, why I'm saying this is because you know at 100 degree or minus 100 degree, it gives you the negative one. So if you choose this at 3 pi, it's 1 minus minus. minus 180 degree. The one in the negative side, you flip it to be positive 180 degree, because one time rotating in the opposite direction, it will give you the opposite of this. So the negative and the positive, they're opposite, but the same magnitude of the angle. And the rest are zeros, 0 degree, because I'm sketching with the angle of CK. You have to be careful, because I remember one student in the exam, he just after he put all these angles, and then he put zeros in the rest, then he put also 0 here. I mean, that's wrong. You can have 0 and 180 degrees at the same time. So that's simply how we did the phase spectrum for the second graph. That's it. So the steps are really clear, and try to practice the problem and do it again. And of course, you should be able to do it using MATLAB. All right, thank you.